Józsi, you've mentioned Knight Rider, but what is that?
Are you saying students won't know it? I'll show you.
Knight Rider, a shadowy flight into the dangerous world of a man who does not exist.
Does that look familiar?
Yes, it rings the bell. After this little warm-up, welcome everyone from the studio. It is the second video of the 11th chapter of the Crystal Clear Electronics video series. In this part, we will learn about registers and the fuse bits of the microcontroller. You have the floor.
Registers are used to store data, and with their help, the peripherals inside our microcontroller can be configured, or we can read data from them. The size of a register is usually given in bits and can vary between 8, 16 or 32 bits, or even 64 bits in newer microcontrollers. You can imagine a register as a shelf divided into equal sections corresponding to its size. We can place something or take something out of these sections, which correspond to the bits of a register. Anyone who has studied programming can imagine the register as a one-dimensional array with each element containing information about a bit, a 0 or a 1. In the picture, you can see one of the registers called the porter register from the microcontroller's datasheet. It is an 8-bit register, and every single bit can be written or read. There are some registers where some bits can only be read. The initial value means the default value of each bit after turning on the microcontroller. In this case, every bit will be 0. Previously, I've mentioned that we store data in registers. In microcontrollers, we use memory to store data. You can guess from this that registers are nothing but small sections of memory. In order to reach these small parts of the memory, we need their addresses, which tell us where exactly these sections can be found inside the whole memory. All the registers have a fixed address that never changes. Remembering these addresses would be hard, and in many cases the registers are on different addresses in different models of microcontrollers. To avoid having to rewrite our whole program and hope that we didn't mess up any of the addresses, we could use a little help. It's much easier if we only need to write down that the porter register's value is 0 instead of searching for the address of the port register in the datasheet and writing the value 0 to this address. For most microcontrollers, the manufacturer usually publishes a header file where all the names and addresses of the registers can be found. This header file can be included in our program, and we can refer to registers by their names. After talking about the registers, let's move on to the fuse bits. At this point, it probably won't surprise you that the fuse bits are inside the register too, namely the fuse register. The most important settings of the microcontroller can be set with the help of these fuse bits. Be careful, a badly set fuse bit will permanently sever the connection between us and the microcontroller. In this case, we won't be able to program our microcontroller anymore. You can see the fuse bits of the ATmega in the picture below. The description of every single bit can be found in the datasheet. Now we'll discuss only those which will be used further on. One of the most important bits is the SUT_CK cell, which is not just one bit, but a setting that has 6 bits. With it, you can set which oscillator the microcontroller will get the clock signal from. In our example, the built-in 8 MHz internal oscillator is selected, but later you can build a circuit with a more accurate external oscillator. In that case, you will have to choose the correct oscillator here. This setting is very important because if you set the wrong value, then the timings will be wrong and the peripherals won't work properly.
We have already shown you how to access these settings in chapter 9, but just to be sure, let's check again. First, connect the power supply and the programmer to the appropriate place on your panel. Then, connect the programmer to your computer. Next, open the Tools menu, Device Programming. In the drop-down menu at the top left, you can select your programmer. In our case, this is Atmel ICE. In the device field, select your microcontroller and set interface to JTAG. After pressing the Apply button, some settings will appear. Click on the Fuses tab. Here you can set the previously mentioned value. It is important not to change anything else.
In order to save the settings, you must click on the Program button. When you click on Program, the values of the fuse register are saved inside the microcontroller, and the microcontroller will use these values at the time of next launch.
We are closing the video with this important setting. Stay tuned for the next part, where we'll take a closer look at the program introduced at the end of Chapter 9. Bye!
Bye!